We are on 1.06 Algebra 2 Notes today, and we're talking about the quadratic formula. And hopefully you guys remember the quadratic formula from algebra. You may have seen it a little bit in geometry as well. But it's a formula that you should already have memorized, and if you don't, you need to memorize it now. We use it to solve equations. So in order to use the quadratic formula, you have to have an equation. It will not work if you have an expression. So you have to have that equal sign. So ax squared plus bx plus c equals 0. The formula is x. I'll sing it to Pop Goes the Weasel. And that helps to remember it. You probably already learned it like that as well. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I apologize for my singing voice, but you get the idea. The discriminant, which is something new that we're going to be talking about this year that you probably didn't in the past, is something we use to describe the root. So we can use it before we actually solve, so we know what method to use, because quadratic formula is going to be your best bet if you have irrational roots or imaginary roots. But if you have rational roots, then factoring using P's and C's or guess and check is going to be a little bit faster. So the discriminant is just b squared minus 4ac. You'll find that right underneath the radical. So it's whatever number is underneath the radical is called our discriminant. So let's go through a problem just to review how to use quadratic formula. So the equation is negative 7x squared plus 2x equals 9. So a couple things we need to do first. We want to get it into standard form. In order to do that, you want to make sure that x squared is positive. The way we know we need to get it into standard form, because half the battle here is when students see this equation, they're not sure what to do. And a lot of students try to get x squared by itself and then take the square root of both sides, and that doesn't work. We just can't solve it that way. So whenever you see an x squared and an x, you want to get that equal to 0. Once you get it equal to 0, then you can decide if you need to factor it using guess and check, P's and C's, or if you need to use quadratic formula or completing the square. Completing the square can be used on every equation, just like quadratic formula. So to get this into standard form, I'm going to add over my 7x squared since it's negative and I want it positive. And then I'm also going to subtract over the 2x. So I'm going to add 7x squared and subtract 2x from this side. So now I have 7x squared minus 2x, and then this is a negative 9, so minus 9 equals 0. And standard form, not only is that equal to 0, but it should be that your exponents are descending. So we have 2, then an exponent of 1, then no exponent. Now we want to find what our a, b, and c are. So a is the coefficient of your x squared. And again, this is from this right here, ax squared plus bx plus c. So a is going to be 7. You do not take the variable, just the coefficient. B is negative 2, and C is negative 9. Once we have those, it would be good here to practice writing out your quadratic formula. And you can sing that to yourself. I'm not going to sing it again on the video, but you are welcome to sing it out loud at home or in your head. And we're going to use the quadratic formula, and we're also going to find, before we actually start on that, we're going to just do the discriminant off to the side here, because I want to use the quadratic formula to solve, so I know I want to use that just to practice it. So maybe the directions here would say solve for x using the quadratic formula. So b squared minus 4ac would be negative 2 quantity squared. Make sure that's in parentheses. If it's not, it will not work out, or you will lose points for not putting it in parentheses. And you're going to type this whole thing into your calculator all at once. So what I mean is go to your calculator And in your parentheses, type in -2 quantity squared minus 4 times 7 times -9. And we get 256. So my discriminant is 256. That's going to be the number underneath the radical right here. What that tells me is that because it's a perfect square, so imagine 256 under a square root. Would that be a perfect square? Yes, 256, the square root of that is 16. So since it's a perfect square, it tells me that my roots are going to be rational. So I'm going to have I'm always going to have 2 real. They're either real or imaginary. And this is going to be rational, and they're not going to be equal roots. So 2 real, rational, unequal roots. So it's really important to know that they're rational. So this number right here, being 256, means my radical will disappear because it's a perfect square. So this tells me that this is actually factorable. So I could have used P's and C's to solve this, but I want to solve it using quadratic formula. So I'm going to continue here. So x equals -b. So I have a -2 as my b, and I want to negate that. So if I negate a -2, it becomes +2. Plus or minus the square root. And now I've already found this, so I'll show you the substitutions just so if you hadn't done the discriminant first on another problem, that's what you would show. And then 2 times a, and a is 7. So now when we simplify 2 plus or minus, we already typed that in our calculator. We know it's 256. 2 times 7 is 14. Now I'm just going to continue to simplify. So the square root of 256 is 16. Now these are all like terms here. So now I want to continue to simplify. So this is like saying 2 plus 16 over 14, or 2 minus 16 over 14. 2 plus 16 gives me 18 over 14, both divisible by 2, so I get 9 over 7. And 2 minus 16 is -14 over 14, which gives me -1. So I have 2 different values for x, -1 and 9 over 7. So again, you see now your answers, your roots, are 2 real, rational, unequal numbers. They're unequal, meaning they're not the same number. So they're both rational, fractional. You can write them as fractions. And that's what our discriminant tells us, this number right here under the radical. That's going to dictate what happens in the process in getting our roots. So we want to use the quadratic formula. So when we have to use quadratic formula at this point, or completing the square, anytime you're going to have irrational, it says irrational, or imaginary roots. So if it says leave in simplest radical form, SRF, simplest radical form, or if it says here, leave in A plus BI form, that's imaginary, those are big hints to us to say, this isn't going to be factorable. You need to use quadratic formula or completing the square. So number 2, solve for x, leave your answer in simplest radical form. So this right here, simplest radical form, is a big, big hint. It tells us that we have irrational roots. If they want them in simplest radical form, it tells us we're going to need to use the quadratic formula. But let's say we didn't pick up on that hint. I'll show you how you could continue going. So this is the equation, x squared equals 6x minus 3. First thing we need to do, no matter what, is I see an x squared and an x, so I need to get this equal to 0. X squared is already positive, so I'm going to keep that positive by bringing everything else over to the left side. So I'm going to subtract my 6x and add the 3 over. So now I have it in standard form. My A is going to be 1, the coefficient of x squared. B, the coefficient of x is -6. And C, my constant, is 3. So let's go ahead and find our discriminant just to make sure that we're going to have irrational roots since we know its simplest radical form. So B is -6 quantity squared minus 4 times 1 times 3. Again, I want you to go into your calculator and type this whole thing right here, just like we did before, into your calculator. Okay, pause if you need more time to do that. And your answer should be 24. So we're looking at 24. You should be asking yourself, if you visualize 24 underneath a radical, is that a perfect square? No, it is not a perfect square. That means we're going to have irrational roots. So you'll have 2 real irrational roots. Anytime you have irrational or imaginary roots, you cannot use factoring, which means you cannot use P's and C's to solve it. So now we know we have to use quadratic formula. So let's practice writing out our formula. Pause it, see if you have it memorized. Okay, so here's our formula. Hopefully you have that memorized at this point. And then we're going to start to sub in. So I have B is -6, so negative B, -6 becomes a +6. Square root of, we've already put B squared minus 4AC in our calculator. Again, I'll show you those substitutions in here, but then I'll just write it in since we already put it in our calculator. And 2 times A is 1. So now this is going to give me 6 plus or minus the square root of 24 over 2. Now, very, 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 very important, before you simplify, you must put it in simplest radical form. So put in simplest radical form before you simplify. And that's where I have to take off a lot of points because a lot of students try to simplify like the 6 and the 2. We can't simplify the rad 24 and the 2 because one's under a radical and one's not. But some people try to do the 6 and the 2 even, and that still won't work. You have to have this in simplest radical form first, and the 2 has to go into both the terms above it. So let's go ahead and put it into simplest radical form now. So we've got 6 plus or minus, the largest perfect square I can take from 24 is 4 times 6. Remember to always write the perfect square first. So this gives me 6 plus or minus 2 rad 6 over 2. Now that you have these 3 numbers, the 3 non-radical numbers, all divisible by the same thing, you can reduce them. I'm going to have you guys always separate it because one of the mistakes students make is forgetting to separate it when it's imaginary. So I figure, why don't we just always separate it? And that way you don't have to remember when you do and when you do not have to. So 6 divided by 2 plus or minus 2 rad 6 divided by 2. Now reduce each fraction. So 6 over 2 gives me 3, and 2 divided by 2 is 1. So our final answer for our roots is 3 plus or minus rad 6, or you could write that as 3 plus rad 6 and 3 minus rad 6. Either way is fine. All right, let's do one more. And then we'll just set up a table to show about your discriminant, what you can conclude. So solve for x. 3x squared minus 2x plus 1 equals 0. So again, I see an x squared and an x. I want to make sure I'm equal to 0, which I am. And now it doesn't say here that I needed an a plus bi or simplest radical form. So I'm going to find my discriminant first just to check to see what I should use. So we've got it equal to 0 already. So a is 3, b is -2, and c is 1. So -2 quantity squared minus 4 times 3 times 1. Take a moment, pause, put that whole thing as you see it right there into your calculator. And that should give you a -8. Now, if you have a -8 underneath a radical, so this is your discriminant right here. If you have a -8 underneath the radical, what kind of roots would you have? Well, anytime we have a negative under the radical, you're going to pull it out and make it into an I. So that means we're going to have 2 imaginary roots. So this question could have said, leave your answer in simplest A plus BI form, which is our form for imaginary numbers. Okay, so imaginary roots. Anytime the discriminant is negative, you will always have imaginary roots. Pause the video, take a moment to write out your quadratic formula from memory. So x equals -b plus or minus the square root b squared minus 4ac all over 2a. And then we're going to substitute in. So we have -b, so they're up here. So -2 is a 2. Show our substitutions. -2 quantity squared minus 4 times 3 times 1 all over 2 times a, so 2 times 3. 2, that looks like a negative. It's giving me a lot of extra lines today. And then underneath our radical will be our -8. Again, you're typing in this whole thing into the calculator at once, which we already did. When you do it, you should not be typing in the square root with it. 2 times 3 gives me 6. Again, before I simplify, I must put in simplest radical form, SRS, simplest radical form, before you simplify. Very, 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 very important. So whenever I have a negative underneath the radical, I'm going to pull out an I, and then it becomes +8 in there. The largest perfect square we can take from 8 is a 4 times 2. Simplify this now, we get 2 plus or minus 2i, because the square root of 4 is 2, rad 2 over 6. So again, you're going to look at your 3 non-radical numbers. So this 2, and this 6. They're all divisible by the same thing, so we can divide them. But what I would recommend doing is splitting it up instead. So do 2 over 6 plus or minus 2i rad 2 over 6. So they keep the same denominator. We're just putting it with each term in the numerator. And now reduce. So 2 over 6 gives me 1/3. Plus or minus, again, 2 over 6 is 1/3. So I rad 2 over 3. Now this form right here is extremely important because this is A plus BI form. If you left it as 1 plus or minus I, this is not cooperating, 1 plus or minus I rad 2 over 3, that would be wrong because it's not an A plus BI form. A plus BI form means they have to be separated. Must be separated. I apologize for the writing. And again, you could write as 1/3 plus I rad 2 over 3 and 1/3 minus I rad 2 over 3 as well. All right, so that's one of each of those. And then now we're just going to summarize the 4 situations for the discriminant. Okay, so option 1. You could have your discriminant, which is b squared minus 4ac, the number under the radical, be greater than 0, which means it's positive. If you don't know that greater than 0 means positive, you should write that down. Also, let's say that it's a perfect square. If that's the case, you're always going to have 2 real, rational, unequal roots. most important word here. So each of these, there's going to be one word that's most important. This one, the most important word would be rational. If we looked at a sketch of what this graph would look like, it would be a parabola, your quadratic, hitting the axis, x-axis, in two nice points. So maybe two integers or two rational numbers. It could be fractions. Next option, b squared minus 4ac is greater than 0 still, so still positive, but the discriminant is not a perfect square. So let's just talk about an example of what that could be. A number that's positive and not a perfect square. So maybe 3. It could be 8. It could be 27. Where here, an example of a discriminant that's greater than 0 that is a perfect square could be 4, 9, it's comma 9, 16, 25, anything that's a perfect square and that's also positive. So if this is positive and not a perfect square, we're going to have two real. This time they're going to be irrational because they're not a perfect square underneath. Sorry, that's really hard to read. For some reason the pen is a little delayed. Irrational. Is our most important word here. Two real irrational, again, not equal roots. So on your graph, what it would look like is, again, it would hit the axis 2 times, but the 2 times where it hits, they would be irrational numbers. So you'd have like long decimals there. Okay, so that's our first 2 scenarios if the discriminant is positive. Let's say the discriminant is equal to 0. So if your discriminant is equal to 0, that's going to tell you you have 2 equal roots. So there'll still be 2 real. They'll be rational because you're just adding a 0 or subtracting a 0 from a number. But most important word here would be equal. So this was irrational. This was equal roots. Because if you have negative b plus or minus the square root of your discriminant, and your discriminant is 0, you're adding 0 or subtracting 0 to it. It's like saying this, x equals negative b plus or minus the square root of 0 over 2a. So the square root of 0 is just 0. So you're not adding or subtracting anything different to negative b. It's just going to be negative b over 2a for your answer. On the graph, that's going to look like you're hitting the x-axis 1 time. But we say that there's 2 equal roots because technically you'd have 2 factors and they would be equal. So you're never going to have just 1 root. If you have 1 root, it means you have 2 equal roots. And the last scenario is if our discriminant, so b squared minus 4ac, is negative, so it's less than 0. So if you have a discriminant that's less than 0, so for example, like our negative 8 before, or if you had a negative 2 or negative 25, so it doesn't matter if they're perfect squares, negative 30. All that matters is it's negative. So as soon as you see a negative, that tells you you're going to have 2 imaginary roots. And the graph of that means your parabola won't be touching the x-axis, so there's no x-intercepts. Okay, so you should be able to be given be given a discriminant and be able to tell me what kind of roots you'd have. So usually in class I go around and I give people a number and ask them to describe the roots. So think about if I gave you a discriminant of 2. Pause, think about what kind of roots would you have. And hopefully you're saying irrational roots. If I gave you 36 as your discriminant, that's positive, and it is a perfect square, so hopefully you're saying rational. If I gave you negative 100 as your discriminant, hopefully you're saying 2 imaginary roots because it's less than 0. If I gave you 0 as your discriminant, hopefully you're saying 2 equal roots. Anytime it's 0 for your discriminant, you're going to have 2 equal roots. All right, and that is it for the quadratic formula for today. If you have any questions, please let me know, and pie out.